So anybody remember what inverse is? Inverse back in chapter 4. All right, so inverse, it literally means the idea of taking two things and switching them. So for example, the inverse of addition is subtraction. The inverse of multiplication is division. This can play some problems where the inverse of squaring is the square root, or inverse of square root is squaring. So when I'm graphing, the inverse is actually take the x and the y and you switch them. So the inverse of 1, 3 is 3, 1. The inverse of 0, 5 is 5, 0. So when I'm solving for an inverse, we literally take the x and the y and we switch them. The first step is take the x and the y and switch them. So the equation becomes x equals 3y plus 6. And then the second step is, this is actually the most critical step, if you don't switch the x and the y, you won't get an inverse. And then the second step is you solve for y. So I got a multiplication problem here, and I got an addition problem. Which one do I do first? Do I undo the addition problem by subtracting, or do I undo the multiplication problem by dividing? Subtraction. So I'm going to add 6, or subtract 6 from both sides, and I get x minus 6. And then we're going to undo the multiplication problem by dividing by 3. So this is one answer for the inverse. So the inverse would be y is equal to x minus 6 over 3. Sometimes you might see it written as two fractions, because that second fraction sometimes can be simplified. You might see it written as x over 3 minus 2. Or sometimes they'll pull the denominator out and make a fraction out of it and make it 1/3 x minus 2. And this is actually the most familiar of the forms, because this is slope-intercept. Y equals mx plus b. The slope is 1/3, and the graph crosses the y-axis at -2. So again, you can have this show up in different forms depending on what form they're looking for. So sometimes they may say to you, write it in slope-intercept. Y equals mx plus b. So this is, we couldn't stop where we're at right now. This answer is perfectly okay, but sometimes, again, they may want it in a specific form. So that would be slope-intercept. So we got it done. Move on to the next problem. You have 4 left. Steps are the same. First step is you got to switch the x and the y, and then you start solving for the y. Keep in mind, like the previous problem, I'll go back to the previous problem. You have a multiplication of 3 on the right side. Its inverse has a division of 3. In the original problem, we had addition of 6. In its inverse, we had minus 6. We ended up having the 6 divided by 3 because of the division problem, but it wasn't minus 6 to begin with. So keep in mind, as you're working through the inverses, you might find the inverse operation taking place. So here we have a subtraction of 7, so you should expect an addition of 7. In the inverse, here we have a multiplication of 2. So we should expect to see a division problem of 2. A couple minutes, and then this is where I'm going to stop the video after this problem, for those of you that may be watching the video. First step is hopefully you switch the x and the y. How many of you multiply 2 by 2? Get rid of the parentheses. Anybody double the y, double the 7? Maybe 7? Anybody just do order of operations, got rid of the 2 and the 7? Do that. Okay, so 2 ways of doing this problem. I'm looking at both ways. We could undo the multiplication problem first, get x divided by 2, or make it a fraction, maybe a fraction. There we go. 1/2 x, and then add 7 to both sides. That's the inverse in the form of y equals mx plus b. So again, the step here is, again, if you did it another way, your answer may look slightly different. But again, if you're not getting rid of the parentheses, the first step would be divide by 2, which is the same thing as 1/2 x. and then we add 7 to both sides to get it in the y equals mx plus b form. If you didn't do that, and you want to get rid of the parentheses first, you get 2x minus 14, or sorry, 2y minus 14. You add 14 to both sides, like the previous screen, and then we're going to divide both sides by 2. This will be the first form, x plus 14 over 2. But they may ask you to go one step further and put like slope and intercept. So bring the 2 above, and we're going to put it in 2 fractions. There's the 7 I had before, remember? If I pull that 2 out in front, it becomes 1/2, because divided by 2 is the same thing as 1/2. So we get in the form of y equals 1/2 x plus 7. So 2 ways of doing the problem, and we actually end up with the same answer if we take it all the way to y equals mx plus b. Are there any questions? If not, you're going to use the rest of the time to work on the problems. Any questions on these 3 problems?